everybody. The purpose of this video is to go over the homework associated with Section 3 of Chapter 3, Measures of Relative Position. Now, here's my screen. Notice I have my Hawks Learning Systems page up here, my calculator, which I wanted to look like this right here, and my OneNote so I can do a little figuring over here. And as always, Hawks has three sections. One is the Learn section, where it covers the same material that I presented in lecture and also in two previous videos. Here is the practice, where you can actually practice on your homework, and if you have any problems, it will give you feedback. And finally, here is Certify, and notice that you only have to get 67% of all the total questions, including the various parts, correct in order to master this assignment. To get 100, you just have to master it before the due date. Okay, so I'm going to go ahead and get started with practice. And the very first thing that you're going to have to do is to compute percentiles. Okay, and here we're given the weights of newborn babies. There are actually 15 data items, and we want to find the 79th percentile. And as you hopefully might recall, we can find the 79th percentile by figuring out what L is. And remember, L is not the location, it's just where we're going to start. And L will always be equal to the size of the data set, in this case 15, times the percentile of interest divided by 100. So in this case, it will be 15 times 79 divided by 100. 15 times 79 divided by 100 is 11.58. Now, since L is a decimal, the location that we care about is going to be the next higher integer. So the location of the 55th of the 79th percentile is going to be location 12 after the array is sorted. So the next thing we need to do is go ahead and sort the array, and then and once we've done that, we can find the value at position 12. To sort it, we can go into stat. Okay, edit, and first thing we need to do is put in the data. So let's go ahead and do that. 8.0, 7.3, 7.5, 9.1, 8.0, 6.9, 7.1, 8.3, 9.2, 7.9, 7.2, 7.6, 8.9, 8.7, 5.9. Okay, so just make sure that's right. 5.9, 8.7, 8.9, 7.6, 7.2, 7.9, 9.2, 8.3, 7.1, 6.9, 8.0, 9.1, 7.5, 7.3, 8.0. Next, we need to sort the data. To do that, we can go to Stat, Sort Ascending, that's what we want. We need to select L1. To do that, we need to click on List. That will be second, Stat to get to List. We can either hit Enter or 1 for L1, close the parenthesis, and hit Enter. When it says it's done, that means the data is in L1 is now sorted. We can see that by going to Stat and looking at L1. And notice it is indeed sorted. And we want the 12th location. Okay, so let's just come on down to 12. Right there, 8.7. So it turns out that for our case, the 79th percentile, P79, is going to be equal to 8.7. Oh, correction, 8.7. Okay, let's see if that's correct. And indeed it is. Now, the next three questions all have to do with z-scores. Okay, now here we're looking at it, we want to consider a set of data where the sample mean is 88.3 and the sample standard deviation is 6.3. And we want to calculate the z-score given that x is 79.8. So we want to figure out the z-score. Remember, the z-score is the number of standard deviations away from the mean. That value is, and that's going to be equal to x minus x bar, the sample mean, divided by S, which is the standard deviation. X happens to be 79.8. Okay, sample mean is 83.3. Divided by 6.3. Okay, so let's go into our calculator. First, let's go ahead and quit, and we can compute that by computing first parenthesis 79.8 minus 83.3 close the parenthesis divided by 6.3. And that gives us negative 0.5555, basically running 5. Okay, we want to round this to 2 decimal places. So here's from decimal place 1, decimal place 2. Notice that decimal place 3 is 5 or higher, so we want to round up to .-56. Negative 0.56. There we go. Now we can move on to the next one. Okay. Here we want to compute the standard score given an X value of 35.6, a mean of 41, and a standard deviation of 57. Done the exact same way, except now we're using population parameters. So Z is going to be equal to X minus the population mean divided by the population standard deviation. Okay, that's going to be 35.6. Minus 41 divided by 5.7. And we can compute this the exact same way. Parenthesis 35.6 minus 41, close the parenthesis, divided by 5.7. And that gives me negative 0.9473. Okay, once again, we want to round it 2 decimal places. So here's what decimal place 1, decimal place 2, decimal place 3 is 5 or higher, so we need to round up. So that'll be negative 0.95. All right. And now here for this one, we actually had to compute 3 z-scores. Let's go ahead and walk through this just for a second. 3 potential employees took an aptitude test. Each person took a different version of the test, and the scores are reported below. Demetria got a score of 71.4. Her test had a mean of 66.6 and a standard deviation of 8. Norma got a score of 258.3 with a mean of 238 and a standard deviation of 29. Caitlin got a score of 8 with a mean of 7.2 and a standard deviation of 0.4. Okay, so now we can actually go ahead and figure this out on our calculator. First, using this approach right here. First, let's take a look at Demetria. Okay, so let's go ahead and do parenthesis. Her score was 71.4. All right. The mean was 66.6. Close the parenthesis. Divided by 8. So there's the z-score, 0.6. Norma next. Norma had a score of 258.3. The mean was 238. Close that parenthesis, divided by 29. Okay, her z-score is a little better. And then finally we have Caitlin, parenthesis, mean of 8. No, I'm sorry, score of 8, minus a mean of 7.2, close the parenthesis, divided by 0.4. And she has a z-score of 2. So we have 0.6, 0.7, and Caitlin is all the way up to 2. I think Caitlin's the one we want to offer the job first because she has the highest z-score. Okay, and this brings us to our last problem, which has 5 parts, but it's not really that bad if we pay attention to what's going on here. Okay, the first thing that they tell us is that we have a mean salary of $26,500. I'm going to assume that this is the entire population of the plant. And a standard deviation of $5,300. Okay? We also know that the median is equal to $24,600. Now, remember, the median is the number in the middle. As a consequence, this is also the 50th percentile, right? Because half the numbers are equal to that or less. It's also known as Q2, the second quartile. All right, and then finally, we have that the 61st percentile, P61, is equal to $30,600. Now, what does this tell you? This tells you that 61% of the salaries are less than $30,600. So here is my kind of like the number line. Here is P61, 30,600. 61% of the salaries are somewhere here and below. Okay, so that brings us to our first question. Based upon the information given, determine if this statement is true or false. Approximately 60% of what salaries are above 30,600. That would be false. If this is the 61st percentile, that tells me that 61% of the salaries are going to be below 30,600. So this answer would be false. It would be true to say that approximately 39% of the salaries were above $30,600, but not 61%, because this is that is how the percentile is defined. Okay, moving on. Next one is Joe's salary is of $37,500 is 2 standard deviations above the mean. Now, to figure that out, we need to compute Joe's z-score. Okay, now remember Joe's z-score, I'm going to just call it JZJ, it's going to be equal to a salary minus the mean divided by the standard deviation. This will tell us how many standard deviations the salary is from the mean. Now, his salary is $37,500. The mean is $26,500. Sorry, a little typo there. And then the standard deviation is 5,300. Okay, so we can just go ahead and compute that. 37,500 minus 26,500, close the parenthesis, divided by 5,300, and that gives us 2.0. So it is not 2 standard deviations above the mean. It is more than 2 standard deviations above the mean. And therefore the answer should be false. Okay, moving on. Question 3. We only have 3 parts left. The means, okay, the percentile rank of 26,400 is 50. Okay, so remember the median is 24,600, which, by the way, is the number in the middle, so therefore it is the 50th percentile. This answer will be true. We actually kind of specified that right there. Okay, then next, approximately 11,000 of the salaries is going to are between 26,400, which is the median, and 30,600. Is that true? Well, actually, it turns out it is, and let me show you why. Okay, so we've kind of just already established that 61% of the salaries are over here. Okay, here is the median, right there. This would be 24,600. Okay, 50% of the salaries are less than this, or is equal to this or less. All right, so we have 60% here. We have 50% here. What is this gap? 11%. And what is this? The salaries between the median and the 61st percentile. So this would be true. All right, and then finally, for our last one, we need to compute. We need to compute the salary for Tom, and Tom's salary has a z-score of 0.8. How much did he earn? Well, we can use this equation right here to figure that out. Okay, so let's start off with this, and notice the z-score is 0.8. That is going to be equal to x. We don't know x, minus the mean, which is $26,500. Divided by the standard deviation, which is $5,300. So we have a little algebra that we need to deal with. Okay, we need to figure out what x is, and of course, to do this, we have to get x by itself. So the first thing that we might want to do to make that happen is to multiply both sides by $5,300. Okay, these will cancel. So on this side, we will have x minus 26,500. And over here, we will have 5,300 times 0.8, 4,240. Okay, then to solve for x, notice here we have this term, just got to get rid of it. We can do that by adding 26,500 to both sides. Remember, whatever you do to one side, you have to do to the other. These will cancel. All we have over here is x. That'll be equal to 4,240 plus 26,500. And that will give us $30,740, which I'm hoping is going to be the answer. 30,740. Okay, let's go ahead and see if that's right. 30,740, and there you go. And that is how you do all the problems in your homework. Now, remember, even though you only need to do 64% of them, I would encourage you to do them all, because this problem that we just walked through is your very last problem. This will probably be the one that you skip. This will also be the one that you're going to see on your exam. So you want to make sure you know how to do this problem in all 5 parts. Because if you don't and you blow through it, you are going to get burned. Well, that is all that I have for this particular video. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.